So we've introduced the idea of the imaginary unit, which is the square root of -1, which we denote as I. We also see that if I is squared, it's equal to -1. But I isn't just left on its own. Although it's considered imaginary, it eventually adds on numbers every now and again, where we can say it's a complex number, which definitely sounds like it's complex, because you have an imaginary unit with some coefficient, and then let's say that we added on some number that was considered real, like 10 or -3, some other number that's not 0. We say that this is considered a pure imaginary number or a complex number. So we'll see how this works. And we see that we can also graph these out similar to how with Pythagorean theorem on a graph of its own in the xy plane. And this is very similar to the xy plane, as if you were graphing a point like 3, 2. Think of it now with the real axis as the x-axis and the imaginary axis as the y-axis. And if you haven't taken geometry or you need a quick refresher, this distance, that consider the absolute value of the complex number, is the distance from the origin to where this would lie on the imaginary complex axis, or the complex number plane. So what the Pythagorean theorem does is find the distance for any side length of a right triangle. The main equation that we use is just taking the square root of everything. So eventually the hypotenuse, or the distance in this case, equals the square root for the change in x and adding on the change in y. And we'll see this graphed out. So if we take a look at this first example here, trying to find the absolute value of 1 minus 3i, we see that graphed here we have 1 minus 3i. We're moving over 1 in the x direction, seen here. We're then going down 3 units in the imaginary direction. So how can we get the absolute value of this? Well, we know that we want to measure a positive distance, so our answer here definitely needs to be positive. If you're good with geometry, you could just take a step back and say, well, I know that one of the side lengths is 1, and I know that this other side length goes down 1, 2, 3 units, so this would have to be 3. So this is as if I'm taking the hypotenuse, or the square root, of 1 squared plus 3 squared, which would have to be the square root of 10. And we would say that this is our absolute value. So this is considered the absolute value of 1 minus 3i. So the distance as far as how it is in the complex number plane. I'll give you a moment for these next two. So we can hopefully see that one of the side lengths here is going to be moving 5 in the real axis. So I'll sketch out how I envision this up here. So 5 for one side length. If we deduct I, we're moving down 1 unit. And then we can think of this as finding the hypotenuse all the way to here. So we can treat this as if it's square root of 5 squared, adding on 1 squared, which is the square root of 26, which we could break down to just 2 root 6 if we're really crafty with our distance. For this other one, it's as if we have a triangle that's moving over 3 units and down 2. So the square root of 3 squared, adding on 2 squared, pretty much the square root of 9 and 4, square root of 13. So very similar to using Pythagorean theorem, finding distance, seen here.